Hello and welcome to Re-enthused. This is just a very quick video. I decided, because a couple of friends of mine were talking about soldering and how they were interested in doing it but weren't really sure about how to go about it. And I'm by no means an expert, but I have been doing a lot of soldering to do with retro projects, so I'm at least capable, and I'm certainly proof that anyone should be able to do it as well. So I figured I'd just make a very quick video about how you can go about it easily and relatively inexpensively as well. So first of all, in terms of equipment, for desoldering, the thing you can hear probably humming in the background is a desoldering station, and they are brilliant, quite simply, and they're relatively inexpensive now. I mean, mine cost I think 70 quid, not cheap, but still far cheaper than they used to be. But I've seen these same models going for about 50 quid. So yeah, the desoldering station is literally just a giant pump and soldering iron which just pulls solder through. Now the cheaper ones like this, they do tend to need a lot more maintenance, but it's maintenance you can do easily enough. It's really mostly just unclogging this part, which is quite easy to do. A set of metal airbrush cleaners does a really good job for these. And the units themselves, it's been pretty reliable. This one I've replaced the gun, but that was because I wasn't sure about cleaning the nozzle until I worked out how to use the airbrush cleaners to do it properly. Once I learned that and realised I had to clean the filter every now and again, because you have to do that, then the actual unit itself has been solid. This is marked as a ZD915. Now I know they're called all sorts of things, but if you look for that you'll see various different models, and it's genuinely worth getting. But if you can't afford that, there are cheaper options. Now, one thing you'll need regardless of how you do it, because it's just useful for soldering jobs full stop, is some flux. Now basically this stuff just allows the solder to flow better, so if you put some down where you're soldering, then it will just make the solder kind of go to the place where you want the solder to go a lot easier, is effectively what it is. You do have to remember to clean up after yourself after using this stuff. It's not really as bad as a lot of people make out. It's not particularly, doesn't attack stuff particularly, it's not especially conductive, but it can cause problems, so it is worth cleaning up with some isolated alcohol. So the methods of desoldering, so you've got, again, so desoldering station, you've got this, which is solder braid, and the way you use this is you well, first of all, definitely put some flux down, put that across the point where you want to desolder, heat up the braid on the solder, and it will just kind of suck the solder in, because it's just metal, so it will take the solder in. It works pretty well. It's good for a lot of big solder joints where you can't necessarily get the desoldering gun in. The by far the simplest method of desoldering, and certainly the one that I used first, was the simple solder sucker. These things you can buy on eBay for a couple of quid. It's just a vacuum pump, and so you just heat up the area of a soldering iron and use that to suck it out. It's never going to sound not rude. So that's I mean, that's the by far the simplest method of doing it. And all these methods, effectively, at some point you're going to need a soldering iron. Do get a good one. Now, for most electronics, you're going to want a fairly fine point, so probably can't focus on that, but this is my one. Mine's a digital one, because I just find it a lot easier to use. You can set the temperature a lot more easily. You can get decent ones, like I've got a much bigger one over there on my rework station. A rework station is not something you'll generally need, it's only if you're doing SMD components, and you can do SMD components different ways, but I like the rework station, makes things a lot easier. So yeah, so that's your basic components. Making sure you have those at hand is really helpful. A good soldering iron especially, don't skimp on the soldering iron. The soldering iron's good, and it's got good tips, and it's good at holding its temperature. It's going to save you a lot of hassle. Now, the solder is more important than I ever thought it was. Watching a few videos from a few people made me realise that just cheaping out isn't a good move. So the solder I've got loads of is this stuff, and you can buy it on eBay for like next to nothing. Now the thing is, this is Mostly, but this one's not actually. I picked up the one that isn't so bad. So first of all, it's quite thick. I would go for a thinner core than that, but not this one. The one I can't find at the moment is doesn't have much lead or any lead in it. And the problem with that is that the leaded solder really does flow better, and it really does last a lot longer, seemingly, as far as I can work out, than non-leaded solder. So I tend to buy a lot of leaded solder. Other than that stuff, I can't find my thin stuff. Yeah, I do recommend getting thin solder because it just means you won't have huge blobs of solder everywhere. That's the basics. The other thing you'll need, definitely, is a nice well-lit area. I have a small LED light, which you can just kind of see there, which just hangs over my area, and a silicone mat as well, which is brilliant. Silicone mats are great. Make sure you keep them clear of metal particles, because I have managed to blow something up by accidentally bridging 2 points because I left a component leg on there. Pure bad luck, but it happens. So as long as you keep that clean, it survives heat, and it isn't conductive, so it's a good place to test stuff and to rework it. Now, what we'll do is, I'll do a very simple one, and it's that I want to be taking off. This here is the motherboard for a Super Cassette Vision, or a Yellow Cassette Vision, depending on where you are, and it doesn't work. And the first thing I want to try is taking a look at some of the caps. I don't see, to be honest, any evidence that the caps are gone. There's not a huge amount of bulging, there's no residue that I can see, and you get a bit of almost like a fishy whiff when capacitors are properly leaked. I don't get any of that. But recapping, may as well. There's not that many caps on here. It is pretty old, so it's probably worth doing. They don't seem particularly high quality caps either, so I take that back. The Nichicons, which are pretty much the best, but it's worth doing. We need to find out what they are, so what we're going to do is desolder them. So I will try to get a good angle on the mat over here. Right, there you go. So that's not a brilliant angle, but it's an angle. So you know what this cap is. This cap is 2200 microfarad, 10 volts. Right, so right, capacitors. I guess we might as well talk about capacitors. So I'll put the capacitor on screen, and so you can take a look. So there are a couple of markings on the capacitor. It's the most important one is its actual capacitance. So that's the actual one that's generally, it's got a UF next to it, which is microfarad. Now that is the important one. That's the one you have to get exactly right, and that's literally yeah, it's the single most important part of that. There's also a voltage, but that's really the max voltage that it needs. Now for capacitor, all you have to do is get at least that. So as long as it's that or higher, you're fine. It doesn't have to be exact. But they say, yeah, the actual capacitance does have to be exact. Now on most capacitors you'll also see there'll be a grey line down the side, and that's because a capacitor has polarity. It has a negative and a positive side. So the grey line there is normally the negative side. Now there are some other markings, but that's generally what you'll see nowadays. There are also ones that don't have polarity, but you don't really have to worry about those. You don't see them that often, and it doesn't matter which side they go in, so it doesn't matter. But for these ones you have to be careful to make sure it goes in the correct way. Normally it's marked on the actual board itself. There'll be a plus or well, usually a plus. They don't usually bother putting the minus. This board, if you can see, actually has both the plus and the minus, so you can see which side it goes in. But normally at least the plus is there, so you know that the grey side goes the opposite of that. It doesn't go onto the plus side. So those are the things to be careful of, and definitely be careful of them for capacitors. Like I said, generally the ways to tell if it's going is there'll be a bulging. This top bit you'll see with these lines. Generally you'll find that starting to open up or bulge out, or the sides bulging out. There could also be like a brownish mass underneath, which is the actual capacitor fluid coming out, and generally a slightly fishy smell is a good sign that there's been a leak. Right, so what we're going to do is we are going to remove one of the capacitors. Now I think we're going to start with this one here, because it looks like it's a bit tatty, so I don't know, it's literally just because where it's been put in or because something's happened to it. But if we look underneath, we can see that these 2 points here are obviously where it is. So what we are going to do, and it's going to be interesting if I can get a good angle for this. So yeah, so these 2 points here, you can see those are the ones we're going to be removing. So what we want to do first, and this is a little bit counterintuitive possibly, is we're going to want to put some actual fresh solder on there. Now the reason for this is that solder's been on there for a while, it's probably a little bit crusty, it won't be flowing particularly well, so if we put some fresh solder on there, there'll be some flux in there, because most solder has a flux core, and it will just make the solder flow a lot easier. So the important thing about soldering is we're taking the solder to the heat, not the heat to the solder. So what we do is we want to touch both the actual part of the motherboard that it's connected to and the leg which is protruding, let them both heat up, and then we'll take the solder in and just give it a dab. Leave the solder iron there for a little while because it's going to have to flow through, and we get a nice bit of solder on there. There we go, and for the other one just give it a dab where the heat is, and there we go. Now there is frothing a little bit, which is another sign that something's happened, or it could just be a sign it's dirty to be fair, so we won't really know. Now we're going to do these first ones with the desoldering tool. So desoldering tool is nice and easy. We put it over, there's a hole in the tip, we put it over, we give it a bit of a wiggle, and then we keep wiggling while we pull the trigger, and that should get all of the solder. You don't want to just put it up. Oh, and that literally just fell out. So you don't want to put it just pull the trigger and then let go. You want to pull it a bit longer because we're trying to get all the solder from out of it, and it could be on both sides because it's a through hole component. So as you can see, we have some nice clean holes there, so that was good. Now then, if we look on this side, it's very dirty. Maybe that did leak. Yeah, that's quite crusty. It's going to be hard to see. I might take a photo and show it up separately. The focus there's at the top, just by this, you can see there's a plus symbol, and that shows us the side that the capacitor needs to go in, so we know that the grey line has to go the other side. First of all though, we have to find out what that capacitor was, because we don't know. I think that was it. I'm hoping that was it. It bounced off. So this was a 330 microfarad at 10 volts. Now we should absolutely have some of those. So let's go hunting with a parts box. Okay, so it turns out we're in fact out of 330s altogether, which is great. I've got a million types, but not that type. However, this one here is 10 microfarads at 16 volts. Now we have 10 there we are. 10 microfarads at 25 volts. Again, capacitance is correct. The voltage isn't, but that doesn't actually matter as long as it's more, and it is. So let's do that again. We should probably also at least make a note of what that other one was, just to make sure we don't forget later on, and we'll definitely forget. Right, so we want to, there we go, desolder. You can just about see those. These 2 points here. So again, we are going to put the heat on the pin and the pad, and then take the solder to that point. Leave it for a second so that it flows. It's definitely bubbling, which is never usually a good sign. So it does suggest there's been some kind of leak going on. Right, anyway, that's both sides done. So now we can bring in the desoldering tool again. Give it a wiggle, and the other side. Now those haven't immediately come out, so that might mean that that's not desoldered cleanly. It does move, but basically if it doesn't come out immediately, and this is especially true for chips, which is something I will do a piece on, is what you really want to do is you want to get some, wherever they are in this mess, needle nose pliers, and you don't want to be ripping the components out because the tracks can be delicate, especially on old machines, especially things like Sinclair Spectrums. The pads will just come off, so you want to go on the bottom, just take some needle nose pliers, give it a little wiggle, and you'll probably hear a click when the solder comes free, and do the same on the other one, and then just gently move it around, and yep, there we go. So we can see that those pads are now moving, the legs are now moving. So we go this, it should just gently come out. There we go. Right, really hard to get this in shot. There we go. Now before we solder anything in, and again you can see there's a plus side on the pad to show. You can just see that little plus sign there, just tell us which way this component is supposed to go. So the grey line will go the opposite of that pad. Now before we solder anything in, we want to be cleaning this up because there is some kind of nastiness there. It may just be flux, it may be something else, but either way we want to clean that up. So what we're going to do is we're going to take a humble toothbrush. We are going to swirl it around some isopropyl alcohol and then give that a bloody good clean. So there we go, we'll just do that just to clean off those edges before we solder in. We're also going to do that on the other side, but we'll wait until we solder before we do that. There we go, those are much nicer looking. Yeah, now again, these caps, they are the correct capacitance. That is a tricky word to say. So the voltage, as long as it is more or equal to what the original one was, and if we look, you can see that this was 10 microfarads. Farads. I'll take a photo of this because I'm never going to get it focused on the camera. Yeah, 10 microfarad and 16 volts. Again, that's a maximum, and so as long as this is at least as good, and this is in fact 10 microfarads at 25 volts, so perfect. So there's our, not grey this time, but there's our lines. You can see that there's a little stripe on one side and there isn't on the other. So we know that the plus is the bit that doesn't have the stripe, and we know there's a plus on this board. So we make sure that the non-stripy side goes towards that. It's also got the longer leg on the actual capacitor as well. So we put that through. And there we go. Now I want to make sure that sits nice and flat, mostly for neatness, but also so it doesn't go floating anywhere or accidentally touch something. Now what generally you can do with capacitors is just bend the legs over and it will hold it in place, and that will give you enough grip to be able to solder. The other way is just to hold it in and tack it. I'll show tacking when we get around to doing an actual chip. Now again, some people will put flux on here. Now I generally don't bother if I'm just doing two legs. It just kind of saves a bit on the cleanup somewhat. There's going to be some, but again we are now going to want to touch both the pad and the leg, and then when they're heating up we can just bring the solder in. There we go. Leave it for a second because again that's going to have to go, not only give a good mound of solder this side, both for contact but also for mechanical grip, but also go through to the other side of the board as well to do the same there, and the same on this one, a little harder to see. Hopefully you saw some of that. I can't tell. It really is bubbling. There really is something horrible happened there. We'll clean it up. Right. So now that's done. We just take a look at the actual board and make sure that's nice and low, and it is. You can see there's no gap there, so that's good. And there's our solder points there, they're nice and rounded. Now we need to cut off these legs. Now I was always taught that you don't cut where the solder is, you cut just above it, because if you cut where the solder is, you kind of weaken the joint, and also you add the possibility of oxidization. Now I don't know how true that is, because I've seen plenty of far more experienced solderers than me that just cut it like that. I still do it because that's how I was taught. But so you leave a little bit of a sharp pin there, but that means that that's nicely held in. And now we go to our toothbrush again, and we're just going to give this a clean, get rid of all of the residue that we've left behind. We're also going to clean the pads that we accidentally desoldered. Well, not accidentally, but didn't have anything to replace them with. Now we can test this. Yeah, we can test this capacitor and see if it actually needed to be replaced at all. Yes, we could if I could find it. There it is. So there's a couple of ways of testing it. The best way is to get yourself one of these meters. It's upside down, there we go, one of these meters. These are really cheap online. Now that's not going to work for this one because the legs have been caught. Maybe it will. You take that off, maybe that'll work. That might do it. I think there's some contact there. Oop, no, maybe not. I'm not sure there is. Well, we'll try it. So we'll put it in there, and if we turn this on, there you go. So we do have a reading there. 322 microfarad. Well, that's not too bad. Yeah, that's not so bad. It's not looking particularly bad on the bottom either. There's no obvious signs that it's leaked. So maybe we will just put this back in for now. I probably still will replace it, but at least that means when we go to replace it, we'll actually have something in place, so we know exactly what it was. So, well, this is a good way of showing you this method, because obviously we can't bend the pins over on this one because there literally are no pins left. So that's over here. You can probably see it moving. So we're going to hold that so it's nice and flat. Now obviously we've only got two hands here. You can use one of these little helper things, but they're not. These little helper things, but they're not always particularly helpful, especially in things like this. There's always a chance that they'll just slip out. If I can find the end of the solder, which is over here. So basically, the way I do this, now what you can do is just put some. I want to leave that. So the idea is you just want to put a bit of solder on the tip. Now the best way of doing this is just to put the solder on the tip first and then put the component in place. But seeing as I've already got the component in place, I'm not going to bother doing that. I'm just going to wait for the solder to heat up again. So all we're going to do is we're just going to touch the solder with the soldering iron, and it will just place a little bit of solder on the tip, and then if we just do the same thing again that we were doing before by heating up the pad and the pin, the bit of solder that we've got, we'll just tack that on. Now what that means is it will just hold it for us while we solder. So now we can solder the other part, the other pin, properly while it's being held in place. You want to be relatively quick by this because the heat will travel through. So there you go, so now we've got to solder that, and then we can go back once that's holding that in place and solder this one properly. There we go. Turn this off so we can... There we go, we hear ourselves think. Right. The last thing to do will be to clean this off. A little bit more. That's a purple there, I think. And there we go. So we have replaced that original cap, although it's a lot straighter than it was originally. And we've managed to replace one of the caps. Now there are others we can go through and replace, I would imagine. We need to find out what they are. So we'll probably have to take a few of them out just because we can't actually see them because they're behind this shielding and stuff. So I mean, total, what we got? We got 1, 2, 3, 4, 6 caps to replace on there. One big one to replace on there. So 7 in total. I will order up the parts and do that, and we'll see if that fixes this. I'm not sure it will, although I'm more sure now actually. I'm more convinced it might now because there's definitely something going on with this board. The way the solder was bubbling usually suggests that there's some kind of foreign liquid on there. So maybe. Anyway, that was just supposedly a quick video. I think it was a bit longer than I expected it to be. There are other tutorials on soldering. You should definitely check those out. But I think this hopefully has shown you that it's not a difficult task at all. It's definitely worth doing, especially for things like recapping. As long as you're careful and you understand what you're doing, and literally everything I just said is all you should need to know. Then it's something you can do without having to ship it off somewhere. It's well worth doing. Although I would definitely hesitate for doing any CRTs because they have massive risks of their own, and obviously make sure nothing's plugged in while you're doing it. But yeah, it's definitely doable. I will do a few other things, especially when I get around to getting some more of the chips for the 800XL, because I need to replace some of those, and I will show off doing some chips because they're obviously the more complex of these tasks. And I'll also show off doing using the braid and the solder sucker as well. They're very different ways of doing things. They're obviously a lot harder. Well, not a lot harder, but certainly more time consuming is probably the easier way of saying it. The soldering station makes things a lot easier. Anyway, thanks for watching. If you enjoyed the video, please hit like. If you really enjoyed the video, please hit subscribe. If you didn't enjoy the video or you have something else to say, then please leave it in the comments below. See you next time.